Hello and welcome everybody to another walkthrough of MyMaths task. It's 3267 properties of quadratics, so quite a high level at this point in the game, knowing all about the quadratic graphs. Right, so we said in the last graph, plotting 3, that if you have x squared, then we have a u shape, and if we have a minus x squared, then we have like an N shape, upside down U shape. So the shape of the graph is interesting, as an interesting property that we can just see straight away. So for example, these two, this one's going to have minus x squared in it, and this is going to be a positive x squared, just looking at the two graphs. The other interesting points are, where does the graph turn around, called a turning point. So a turning point is an interesting place to look at. Another place, where does it cross the axes, so the intercepts, so they're interesting points as well. Okay, so they're your major interesting points on a quadratic, major properties. What shape is it, where's the turning point, where does it turn around, and what are the intercepts. And the nice thing about the intercept is when you're looking at the y-intercept, so where you're looking at where it crosses the y-axis, the x value is 0. And then where it crosses the x-axis, the y value is 0, and that has effects on the actual equation of the graph. Okay, so let's look at this graph. So the first thing I notice is it's upside down U shape, so it's going to be a minus x squared. So if I'm trying to pinpoint which equation it is, it could be this one because I've got a minus x squared there. This is a positive x squared, so it's definitely not that one. They're both positive, so not that one. It can't be that one. Looking on the bottom ones, it can't be this one, it could be this one, it can't be that one, and it can't be that one. So I've only got an option. I've only got two options just by looking at the shape of the graph. The next interesting part of the graph I'm going to look at is the turning point. So the turning point here, when y equals 0, when x equals 0, y equals 3. Now if I put 0 for x in these two, I'll have nothing plus 1 is 1. 3 take away nothing is 3, and 1 times 3 is 3, so that's okay. And if I put this one down the bottom, I've got, when I put x equals nothing in there, I'm going to have 3 take away nothing is still 3. So this point fits both of these two things. Okay, so what can I do next? The next thing I'm going to look at is not an intercept now, so the intercepts aren't working because it doesn't cross the axes at a nice value for me. So if I just pick another random point on the graph and see which one it works in, which of the two equations it works in. So if I look at this point, for example, this is when x is 1, y equals 2. So over here, when x equals 1, y has to equal 2 for this point in particular. So let's see which one it works on. So when x is 1, I'm going to put 1 plus 1 is 2. And then 3 take away 1 is 2, and 2 times 2 is 4. So this one doesn't actually work for this point, and that's definitely on the graph, so it can't be that equation. If I look down here, when x is 1 here, I've got 3 take away 1 squared, well 1 squared is 1, and 3 take away 1 is 2. So this one, it works, because well, I've just got y equals 2. So this must be the graph of y equals 3 take away x squared. Okay, so let's cross that one out. Let's just cross that one out now. So when I look at the others, it can't be anything else. Now looking at this graph, first of all, the shape of the graph is u squared, so it can't be a minus x squared. So this one, I can't have that one for this particular graph. Next thing to look at is the intercept. I guess this intercept's quite nice, down at minus 3. So when x is nothing, y is minus 3. Okay, so let's have a look. What's it doing to the equation? So when x is nothing, that's going to be nothing. Take away 0 here, plus 4. So this one's going to give me plus 4. I was after minus 3. It's not that one. Put 0 in here. So let's cross that one out. We don't need to worry about that one anymore. When x is 0, we've got 1. And then that's 0 take away 3 is minus 3. And 1 times minus 3 is in fact minus 3. So we could be looking at this one. When x is 0, we've got minus 3 again, so we could be looking at that one. Going down, when x is 0 here, we've got 0 plus 2 is 2, 0 plus 3 is minus 3, 2 times minus 3 is minus 6, so we're not looking at this one, so just process of elimination. Next one, when x is 0, we'll have 0, 0, this is going to be minus 4, remember we wanted minus 3, so that one's out of the game. And this last one, we've got when x is 0, we've got 0 minus 2 is minus 2, 0 plus 3 is 3, minus 2 times 3 is minus 6, so it's not that one. So we've narrowed it down to one of these two. Okay, so now let's look at in intercept. What should we look at here? So when x is 3, when x equals 3, y turns out to be 0. Okay, so that's that point there, when x is 3. So if we put them in the equations, when x is 3 here, we get 3 plus 1 is 4. 3 take away 3 is nothing. 4 times nothing is 0. So that one does work. When x is 3 here, we get 3 squared is 9. Take away 3 is 6. That one doesn't work. And therefore we're left with y equals x plus 1 and x minus 3. Okay, so we've just identified those two. Hard work. Turn over. Okay, look at all these, we've got loads to do. Took me ages to get this set up. Right, next question. Can I see it all yet? Right, so let's look at our equations again. So first of all, the graph. The shape of the graph is a U shape, so it's going to be an x squared. So that wipes out this one. Okay, I've already taken out the 2 from the other page. If I look at now a point on the graph, so let's pick on, which point should we pick on? Pick on that one. When x equals 4, we've got y equals minus 4. So that's this point here. So let's throw that into the equation. When x equals 4 here, we're going to have 4 and 2 is 6. 4 take away 3 is 1. 6 times 1 is 6, so it's not that one. So this one's out of the game for this equation. When x is 4, we're going to have 4 squared take away 3 is 13, so it's not that one. So definitely not that one. When x is 4 here, we're going to have 4 take away 2 is 2, 4 plus 3 is 7, 2 times 7 is 14, so it's not that one, so it's none of those three. Down here, when x is 4, we're going to have 4 4s is 16, take away 16, plus 4 is plus 4, so it's not that one, so it must be this one, it's the last one I've got. 4 4s is 16, take away 4 4s is 16, minus 4 is minus 4, so it is in fact this one here. So we've got y equals x squared minus 4x minus 4 for that graph. Cross that one out. Right, the last one. So I've crossed this one out already because it was minus, and this is a positive x squared. If we pick a value, let's go for this one here. So the turning point is when x equals 0, y is to be minus 6. So let's see which one of these gives us minus 6. This one doesn't, so it's going to be 0, 0 plus 4, so not that one. This one doesn't. 0 squared is 0, take away 3 is minus 3, so it's not that one now. These two do, so 0 plus 2 is 2, 0 plus minus 3 is minus 3, 2 times minus 3 is minus 6, that one works at the moment. And this one also works, 0 minus 2 is minus 2, 0 plus 3 is 3, minus 2 times 3 is minus 6, so that one works. So these two both work, so we need to pick another point. Let's go with this point here. When x equals 2, y has to equal nothing. Okay, 0. So let's go, put 2 in, 2 plus 2 is 4, 2 take away 3 is minus 1, and 4 times minus 1 is minus 1, not 0, so it's not that one, must have been this one. 2 take away 2 is 0, 2 plus 3 is 5, 0 times 5 is 0, so it's definitely this one. We've got y equals x, take away 2, and x plus 3 for that graph. Okay, that's one way to find out all the different points, and we'll come back to this idea in a second. Okay, well, not a second, a couple of minutes. Right, the last page was identifying things. Now, a root. The root of the equation. So the root of the equation, x squared minus 2x minus 3 equals 0. So all I've done is x squared minus 2x minus 3 equals y, and now it equals 0. So we let y equal 0. So where's y equal 0? It's here and here. And these are known as the roots of the equation where it crosses over the axis. So this thing is minus 1, x is minus 1 there, and x is 3 over here. Okay. The y-intercept, where does it cross the y-axis? So it crosses the y-axis down here at minus 3, so 0, minus 3. The coordinates of the turning point, so the turning point is down here, so that's 1, and then minus 4. And is it a maximum or a minimum? Well, this is called a minimum point, because that's the smallest that y can possibly get to. Okay, can't go any further down because it's turned on and gone back up again. So this is a minimum, not a maximum. Maximum will be the other way around. Now, just to return to the roots, we've got the graph y equals x squared minus 2x minus 3, and we know the roots are minus 1 and 3. Okay, so what we could do, we could rewrite this equation as x, and then not minus 1, but in the bracket you put plus 1, and then you put x, and not plus 3, but minus 3 in the brackets, and this thing would be the same as that one there. Now what that tells us is, when we're looking at, if we've factorized already in an equation, if we want to find the roots of the equation, if we've got x plus 1, then the root is minus 1, and the root of this one is going to be plus 3. So if I look back at one we did earlier, so this one, we could have said x minus 2, so the root is plus 2, so the graph's going to cross over at plus 2, and there it is. And the graph is also going to cross over at minus 3 from here, and there it is at minus 3 crossing over. Okay, so you can find the roots help you to factorize an equation, or factorize an equation helps you find the roots, one or the other way. And that's it, quite a long video. Have fun.